All right, so let's take a look at 9.3 homework question number 4. We have data on a random selection of actresses when they won Best Actress and actors when they won Best Actor. The ages are matched according to the year that the awards were presented, and um, we're interested in seeing if there's a difference, and in particular whether the average age of the female actors is less than the average age of the male actors. All right, so use the sample data with a 0.01 significance level to test the claim that for the population of ages of best actresses and best actors, the difference have a mean less than zero. In other words, the best actresses are generally younger. All right, so in this example, the null hypothesis is that the mean of the difference is going to be 0 years. The alternate hypothesis is that the mean of the difference is going to be less than 0 years. And then we're asked to find the test statistic and the p-value. All right, so let's go ahead and go to StatCrunch. So I'm going to go to StatCrunch. Oh, you know what? With this particular problem, the data is here. So we want to click to copy the table into StatCrunch. All right. So now we're going to go to Stat. Then we're going to go to T-Stats. Then we're going to go to paired data. So we've used one sample, two sample, and now we're using paired data. And then we want to select sample 1 is going to be the actresses. Sample 2 is going to be the actors. We want to check our hypothesis, and this needs to be changed to less than, and we could go ahead and compute. All right, so our test statistic is negative 2.06, and our p-value is 0.305. So here's our test statistic of negative 2.06. Here's our p-value of 0.035. So what is the conclusion? Well, since the p-value is greater than the significance level, we fail to reject the null hypothesis. We do not have sufficient evidence to support the claim that actresses are generally younger when they won the award. So now, to construct the confidence interval, we have to remember that this is a one-tailed test. Since it is a one-tailed test, a confidence interval is always two-tailed. That means we have 1%, right? Here's our significance level. That means we have 1% in the right tail and another 1% in the left tail, which means we're looking at a 98% confidence interval, not a 99. It's a very important distinction. So what I'm going to do is I'm going to go ahead and go into options and click edit. And we already have this populated, but what we want to change is we want to go to confidence interval. And then we want to change this to 98. And then we're going to hit compute. And you'll see we have negative 19.7 to 3.1. I've entered those values here, negative 19.7 to 3.1. So what feature of the confidence interval leads to the same conclusion? Well, it contains 0. If it contains 0, then you can't say that the difference is not equal to 0. So that concludes this lesson.